Good day, everyone. So, in today's class, we'll be looking at the topic, the gas laws. At the end of the lesson, we'll be able to see how pressure, volume, and temperature govern the behavior of gases, from syringe even to airbag. These gas laws are in theory, and there is a theory that guides these gas laws. It is known as the kinetic theory of gases. The laws we are going to be considering are hinged on this kinetic theory. So let's begin to consider the law one after the other. The first one is known as the Boyle's law. Boyle's law states that the volume of a fixed mass of gas is inversely proportional to its pressure at constant temperature. So there is variation between volume and pressure in this law. So what is the variation here is inverse variation. So what that means is that as you reduce the volume or the space occupied by this mass of gas, then the pressure of the gas on the wall of that container will increase. If you have seen a syringe before, a syringe is what we commonly call the injection that the nurses use in the hospital. You will see that when the nurse presses the piston of the syringe, as you can see in this picture here, this is an example of a syringe, this diagram here. So when this piston is being pressed, it reduces the amount of gases in the container here. It reduces the amount of space rather. And when the space is reduced, there will not be enough space for the gas to move. They begin to exert pressure around the wall of that syringe. That pressure will increase. But when the piston is pulled backward, there's enough space for the gas. That space is the volume. So in that case, the pressure of the gas on the wall of the syringe will be less. So what we are saying in essence is that the volume increment reduces the pressure, while the volume decrease increases the pressure. That's why we say the volume is inversely proportional. So as one variable is going up, the other one is going down. So by formula, Boyle's law says that pressure 1 multiplied by volume 1 equals pressure 2 multiplied by volume 2. That formula is very, very key for our understanding. So we're going to see more example as we go on, but let us consider the second law. That's known as Charles' law. Boyle's law relates volume and pressure and kept temperature constant. But what Charles' law did was to relate volume and temperature and kept pressure constant. And you see that it's a reverse. So what does this law state? Charles' law states that the volume of a fixed mass of gas is directly proportional to its absolute temperature at constant pressure. Okay, why that of Boyle is that volume of gas is inversely proportional to pressure at constant temperature. But in this case now, the volume is directly proportional to temperature, so that the reverse here at constant pressure. So what the law is stating in simply term is that when you increase the volume where these gases is, okay, what that means is that the temperature must have had effect on it. Temperature is taken as the heat. When you increase the amount of heat that is being supplied to this container that have the gas, then you find out that the gases inside they begin to occupy more space. So the higher the temperature, the higher the volume occupied by the gases. So that's what the law is stating, that the volume of a piece of gas is directly proportional to its absolute temperature. So it depends on the temperature. So the higher the temperature, the more the volume occupied. Okay? Alright. Now, pressure must be kept constant. Take note in this case. And by formula, it's going to be V1 over T1 equals to V2 over T2, where V is the volume and T is the temperature. V1 is the initial volume, T1 is the initial temperature. Excuse me. Then V2 is the final volume, T2 is the final temperature. We are going to see more examples as we go on. So let's consider the third law, and that is pressure law, sometimes referred to as Gay-Lussac law, especially in chemistry. In this law, what was quite constant is the volume. For Boyle's law, temperature was kept constant. For Charles' law, pressure was kept constant. But for pressure law, volume was kept constant. Okay, so the law states that the pressure of a fixed mass of gas is directly proportional to its absolute temperature. So what that means is that when you increase the temperature of the gas, okay, they exert more pressure. That's what it's saying. So by formula, P1 over T1 equals to P2 over T2. So it's very, very important that you know this formula. Now, these three laws are now combined together to be called the general gas law. So that in the general gas law, we now have P1 V1 over T1 to be equal to P2 V2 over T2. The three combined together are referred to as the general gas law. That is the combination of Boyle's law, Charles' law, and the pressure law are combined to be referred to as general gas law, or the equation is referred to as the general gas equation. Okay. Now, in the real world application, we have what we call the airbag. We have seen where it's been applied in syringe. Now, airbag also is a safety device that is being kept in the vehicle in the case of accident. Now, how does the airbag work? When there is an accident, okay, or a crash, this crash will make this airbag to begin to rise. And what really happened there is that there is a sensor called crash sensor in it. So when that crash sensor senses any crash or accident, it sends signal to the nitrogen gas in it, and the nitrogen gas begin to expand and fill up this bag, and then you can see that this bag is inflated. So the person in the accident now, instead of hitting his head on the steering or any other hard surface, it hits his or her head on this airbag for safety purpose. So it now begins to serve as a pillow. That's another way we can apply this gas law. So what happened here is that the pressure that was being felt by the nitrogen gas has made it to occupy the volume. Okay, and this talk about it can be applicable to the pressure law. Okay, it can apply to the pressure law because the high pressure leads to what? High volume. Okay, at constant temperature. Okay, now let's see one or two questions on this. Look at this question here. It said a gas at pressure P Newton per meter square and temperature 27 degrees Celsius is heated to 77 degrees Celsius at constant volume. Stop. The new pressure is dash A 0.85 P Newton per meter squared, B 0.86 P Newton per meter squared, C 1.16 P Newton per meter squared, D 1.18 P Newton per meter squared. Explain this power in Newton per meter squared. Then E 2.85 P Newton per meter squared. So let's begin to solve this question one at a time. All right. So let's take it one parameter at a time. All right. So going back to the question, it say a gas at pressure P. That's the initial pressure. Now let's say that's P1. So we are giving P1 to be equal to P1 there is what? P Newton per. So we are giving it to be P. Let's just leave the unit. So we are giving the P1 is P, and the temperature, initial temperature, as T1. T1 equals to 27 degrees Celsius. So you have to convert it to Kelvin by adding 273 to it. In gas laws, you convert your temperature to Kelvin, okay, when you are given in degrees Celsius. So when you do 27 plus 273, that should give us 300 Kelvin, right? So we are having it as 300 Kelvin. So our T1 is 300 Kelvin. Our P1 is P. It's heated to 77. That's T2 now. T2 is given to be 77. Taking it to converting it to Kelvin, that will be 77 now plus 273. All right. So when we do that, we should be having 350 Kelvin. Okay. So that's our T2. So we have to find the new pressure. So that's our P2 now. P2 is unknown. We don't know it. That's a question mark. Our P2 is the unknown part of the question. What we have to find. So now, which of the laws work with this? The one that you have pressure and temperature and volume is kept constant. Which law is this? This is pressure law. Pressure law is the one that varies pressure and temperature at constant volume. Okay, pressure and temperature at constant volume. So going forward, we'll make use of our formula. That would be P1 over T1 equals to P2 over T2. Okay, over T2. Now substituting the value, our P1 is P, so we have P over our T1 is 300 over 300 and equal to our T2, our P2 rather, our P2 is the unknown, what we have to find, and then over our T2 is 350, okay, that's 350. So when you cross multiply this now, so we'll be having it as 350 when you cross multiply it this way, right? You have 350 P to be equal to 300 P2. So since our P2 is our subject, dividing both sides by 300, we have 350 P over 300. So 0 cancels 0 here. Let's use 5 to divide there. 5 here is 7, 5 here is 6. So we have 7P over 6, right? So if you go ahead to solve that, remember this is our P2. So our P2 there will be 6 in 7 is 1. I mean the 1. Then add 0. In this in 10 is still 1. I mean the 4. Then 6 in 40 is 6. Remember that our P is still there. So checking the option here is going to be 1.16 P Newton per meter square. That's option C. Now going to the next question, it said if a given mass of gas at constant pressure obeys the relation volume is proportional to the absolute temperature, the gas is said to obey A. Hooke's law, B. Boyle's law, C. Dalton's law, D. Charles' law, E. Newton's law. Of course, we know Hooke's law has nothing to do with gas law. Boyle's law deals with pressure and volume, and here we have volume and temperature, so it's not correct. Dalton's law has nothing to do with gas law. Gas laws are just 3, and Boyle's law is one of them, but it's not it. Charles' law deals with volume and temperature, so it's Charles' law, not Newton's law. That's the correct option. Okay, so let's solve more question. It's another question here. The question says here that an air column 10 centimeters in length is strapped into the sealed end of a capillary tube by a 15 centimeter column of mercury with the tube held vertically as shown in the figure. This is the figure here, okay? So on inverting the tube, the air column becomes 15 centimeters long. First stop. The atmospheric pressure during the experiment is A. 90 centimeters, B 76 centimeters, C 75 centimeters, D 60 centimeters, E 50 centimeters. So which of the options are correct? Before we can get the option, we need to do a little calculation here. So let's go back to the question again from the beginning. It said, and it says that an air column 10 centimeter in length. So this air column is a space where the gas is occupying. We are taking air as the gas in the question here now. So that means the volume of the gas is 10 centimeter. Take note that this is a peculiar scenario. When we are dealing with capillary tube is this U-shaped diagram here. Okay, we normally take volume to be in form of length. Okay, now the volume of the gas, which is air in this case, is 10. 10 supposed to be 10 centimeter cube, but in this peculiar situation, we normally take it as length. So V1 here, our initial volume here is, so don't get it mixed up, is 10 centimeter, but the original unit for volume is not centimeter but centimeter cube. Okay, now an air column 10 centimeter in length is trapped into the sealed end of the capillary tube by a 15 centimeter column of mercury. Now this column of mercury that has trapped the air is taken to be the pressure that is acting on that air. So please take note of this peculiarity. So here we are also assuming that this is pressure. Initial pressure is 15 centimeters. Okay, but then because this capillary tube is in vertical position and the open end is facing up, so there are two pressures that are acting on the air. Okay, this is the air here. Okay, this is the air. Let me just put some circles here to show that these are the airs. Now mercury pressure is acting on it. The atmospheric pressure is also acting on it from up. Atmospheric pressure from the air. It's also exerting pressure on the mercury, which is also exerting its own pressure on the air. So there are two things acting, exerting pressure on this air: the atmospheric pressure, okay, and the mercury pressure. So now the initial pressure now will be atmospheric pressure. Let's take it as H plus the mercury pressure, which is 15. Okay, 15. So this is the pressure that is acting. This pressure that is acting on this air when this tube is facing up. But going further in that question, it said on inverting the tube. When you invert the tube, that means you are turning it upside down. Upside down means that the tube is now in this direction. It's now upside down. The open end is now facing down. Of course, the mercury is still there. And now this is the air now here. Okay, and of course the length of the mercury is still 15 centimeter. It did not change. But what happened here is that he said on inverting the tube, the air column becomes 15 centimeter. That means there was an increment of the volume of air. So our V2 now becomes 15 centimeter according to the statement. On inverting the tube, the air column becomes 15 centimeter. Okay, now the atmospheric pressure during the experiment is what? You have to find the atmospheric pressure. Now, whenever the capillary tube is inverted this way, okay, now the pressure that is exerting on the air, that is our V2 now, will be atmospheric pressure, okay, minus the pressure of the mercury. The mercury is not exerting pressure anymore because it's as if the mercury is about to fall out from the open space. So we are subtracting the mercury pressure from the atmospheric pressure. You understand? So now, of course, we could see that these parameters here are just pressure and volume. And the law that varies pressure and volume is Boyle's law. So we can say here that we can use the formula P1 V1, that's Boyle's law or Boyle's law formula, equal to P2 V2. Okay. Now substituting our value, our V1 is 10. So we have our P1 rather, P1 is H plus 15. So we have open bracket H plus 15 multiplied by our V1, which is 10. Okay, then equals to our P2 is H minus 15. So open bracket H minus 15 close bracket multiplied by V2, which is 15. Okay, it's 15. So to make my mathematics fast, I can divide both sides by 5. So like 5 here is 5 in 10 is 2, right? And 5 in 15 is 3. So expanding now, 2 times H is 2H plus 2 times 15 is 30. Alright, equals to, at the other end, 3 times H is 3H. Then 3 times 15 will be 45. Now collecting like terms now, we have 30 plus 45 plus 45, all right, to be equal to then we have 3H, the 2H goes to the last side minus 2H. Now going forward there now, 30 plus 45, that will be 75. So let me bring it here. We have 75 equals to 3H minus H is H. So that's our value of H. So our measure is 75 centimeters, and that is option C. Option C. All right. So the last question I will want to give you as a task to do to see if you have actually understood the application of the law. All right. I hope you have learned something from the topic today. Thank you for listening and have a wonderful day. Bye for now.